Welcome to topic 3.9 part 1, inverse trigonometric functions. So it says, as with all functions, the inverse of a trigonometric function is the result of switching the input and output, the x and the y values of a function. As a result, the output value of an inverse trigonometric function will be an angle measure. If you think about how we've been graphing recently, on my horizontal axis, that's where we've been putting theta, our angle measure, and then on my y value, it's just the output, which is the numeric value. So when we switch it, our input will be the numeric value, and our output will be theta, our angle measure. For notation, we can represent inverse trigonometric functions in two different ways. The first way is with our trig function. It looks like it's to the -1 power, just like how we use inverse functions. Okay, so that's inverse sine of x. Or the second way that we can write it is with ARC, so arc sine. So either notation, we can call it arc sine of x, or we can also call it inverse sine of x. Okay, so example number 1, it says, write the statement sine of pi over 6 equals 1/2 in an equivalent form using arc sine notation. So what that means is this. This is my input, pi over 6, and this is my output, 1/2. So when we want to do an inverse or an arc sine notation, what we would say is we would switch the input with the output. So we do arc sine of 1/2, and that would be equal to pi over 6. Or I could use the other way. So inverse sine of 1/2 is equal to pi over 6. So those are my two different ways of writing the equivalent form. So again, switching the input and the output there. Okay, restricted domains of inverse trigonometric functions. Because trig functions are periodic, we must restrict their domains to create their corresponding inverse functions. So we're going to start off by taking a look at sine. So when we want to do inverse sine, what's going to happen is this. Sine is periodic. And so what that means is, on the whole domain, all real numbers, sine is not 1-to-1, meaning each y value is not unique. There are multiple locations for x that have multiple y values. Now, what you learned in Algebra 2 was the idea of vertical line test. So if I draw a vertical line and it only goes through one point, that means that sine is a function. However, when I do a horizontal line test, if I go through more than one point, that means that the inverse will not be a function. So the way to work around that is by restricting the domain to a certain amount of points. So what that means here is this. If we were to restrict the domain of sine only to pi over 2, negative pi over 2 to pi over 2, what you will notice is this function will be 1-to-1 over that spot. Okay, so what that means is no x's are repeated and no y values are repeated also. Okay, so when we do the inverse, we switch the x values and the y values. So 0, 0 is still going to be located at 0, 0 for the inverse graph. Pi over 2, 1, you switch the x and the y values, are now 1 pi over 2. Negative pi over 2, -1 is now -1, negative pi over 2. So what you'll notice is a lot of the points that we know, okay, as far as our flashcards and things like that, if you switch the x and the y values, the inputs and the outputs, that's how you're going to get the graph of inverse sine. Okay, we'll talk about more about the graph later on in part 2, but for now we're just getting an understanding of what's happening here. Okay, the star asterisk there, it says the reason why we have a restricted domain is because it needs to be 1-to-1. The y values cannot repeat itself. Okay, so this is how we come up with inverse sine, and that's why it's only between negative pi over 2 to positive pi over 2. Okay, turning the page, we're going to take a look at cosine. So it says inverse cosine. Similarly, we will restrict our cosine function for the same purposes. However, for y equals cosine of x, we're going to restrict the domain from 0 to pi. And the reason why we're going to do that is, if you take a look at cosine, if I try to use the same numbers for cosine as I did for sine, what you'll notice is the y values are repeating. So negative to positive pi over 2 is not going to work for us there. So what we're going to do is we're going to restrict the domain from 0 to pi. And when we restrict our domain from 0 to pi, we are able to get something that is 1 to 1. Okay, so what you'll notice is when I restrict my domain, the domain itself is from 0 to pi, and the range of this is going to be from negative 1 to positive 1. So when we do the inverse function, the domain becomes the range, and the range becomes the domain because you're switching x and y values. And just like we did for inverse sine, for inverse cosine, you switch the x and y values. So 0 pi over 2, pi over 2, 0 is now 0 pi over 2. And then our values at 0, 1 is now at 1, 0. And pi negative 1 is at negative 1 pi with all our values along the way. So again, what you'll notice is the graph of inverse cosine is also still 1 to 1 because the original function was 1 to 1. Okay, for tangent function, we will restrict the domain from negative pi over 2 to pi over 2 due to the vertical asymptotes. So because I have my vertical asymptotes and negative and positive pi over 2, it allows me to establish a graph that is still 1 to 1. Okay, now notice that for tangent, it still extends itself forever, up and down. So what that means is when you do the inverse, you switch the x and the y values, it's going to extend itself left and right forever as well. Okay, so negative pi over 4, negative 1 becomes negative 1, negative pi over 4. 0, 0 is still itself, and pi over 4, 1 is now 1 pi over 4. And then we also have our other trig values there as well. Okay, so that would be inverse tangent. Okay, so what you'll notice is domain in this is going to be, for the inverse trig, is going to be all real numbers because the domain for regular tangent that we restrict is negative to positive pi over 2, and the range is going to be all real numbers. So that means that the range becomes the domain, and the domain becomes the range. Okay, there are two horizontal asymptotes, and they will be located at y equals plus and minus pi over 2. Okay, so turning the page, important note about inverse trig functions. It is always important to remember and consider the domain, because what's going to happen is whatever's in your domain is going to be the angle measures that we're going to be utilizing. Okay, so quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So inverse sine is going to be utilizing 1 and 4 with a range or output values from negative to positive pi over 2. What that means is when you are evaluating inverse sine functions, your answer for your angle measures should only be between negative to positive pi over 2. For inverse cosine, the range is from 0 to pi. So what that means is your answers, when you evaluate inverse cosine, is your answer angle measures should be between 0 and pi. And then for inverse tangent, just like inverse sine, it's going to be between negative to positive pi over 2. Okay, the reason why sine is allowed to include it, but tangent is not allowed to include it, is because sine exists at those values versus tangent has horizontal asymptotes at those values. Okay, so you have a table here that kind of shows you the domain, and then it shows you the interval on which it occurs at for your range as well. Okay, again, two different ways of utilizing and asking the same questions. Inverse sine, arc sine, inverse cosine, arc cosine, inverse tangent, arc tangent. Okay, the inverse trigonometric functions find a specific angle related to the given ratio. So, if we take a look at example number 2, evaluate the following expressions. I'm going to pause here and let you guys try, and then we're just about done. So inverse cosine of negative root 2 over 2. What they're asking you is this. Cosine of what angle will give me negative root 2 over 2? But here's the stipulation. Inverse cosine happens to have a range from 0 to pi. So theta, your answer, can only be between 0 and pi. So what angle between 0 and pi will give me the output of negative root 2 over 2? and that will be the same for part B and part C. So I'm going to have you try example number 2, and then I'm also going to have you try example number 3. I'll give you a hint for example number 3. They're giving you the output, so you have to figure out which one of these 4 matches with each of the 4 points. Okay, so let's pause here as you try example number 2 and 3, and then that'll be it for the notes today. Okay, so let's go through these. So letter A, which angle measure between 0 and pi gives me negative root 2 over 2. So again, I'll just refer to this table you have right here. Cosine is your x value. So negative root 2 over 2, all students take calculus. So what you know is cosine is negative in quadrant number 2. So your answer is going to be in quadrant number 2. So the value that gives you negative root 2 over 2 in quadrant number 2, that would just be 3 pi over 4. So that would be the angle measure. I can also confirm that by going to the graph that we were looking at a little while ago. So when you look at this graph for inverse cosine, what you'll notice here is they were asking us for arc cosine of negative root 2 over 2. So if negative root 2 over 2 is the input, 3 pi over 4 would be the output. So that would be my answer right there. Okay, for letter B, inverse sine of root 3 over 2. So what we are asking again is sine of what angle gives me square root of 3 over 2. But this time, again, you have to keep in mind that your angle measure has to fall between positive and negative pi over 2. So in order for sine to be negative, sine's going to have to be in quadrant number 4, somewhere down here. Okay, so that's a negative angle down there. So again, if you're not sure where that is, you could think about your graph here. So what I have here is my graph of arcsine, and looking at my graph of arcsine and looking at negative root 3 over 2, that puts me right here. Okay, that's negative pi over 3. If you're utilizing your knowledge of your flashcards, so negative pi over 3. If you're using your knowledge of your flashcards, sine of 5 pi over 3 would have gave you negative root 3 over 2. So if you remember that portion, just know that it takes you 5 pi over 3 to get here, which is the equivalent of negative pi over 3, because 5 pi over 3 plus that 1 pi over 3 makes 6 pi over 3, which completes your circle, one rotation around the circle. Okay, letter C, again, what they're asking me is tangent of what angle gives me the square root of 3. But my angle has to fall between pi over 2 and negative pi over 2. Okay, another thing that you can think about graphically is tangent rises from there. Okay, and so what happens here is I know that tangent has root 3, and I know tangent has root 3 over 3. And so I know that the square root of 3 is larger than square root of 3 divided by 3. That means that the negative root 3 over 3 goes first, and then the square root of 3 goes second, and then root 3 over 3 goes first, and then square root of 3 happens to go second. And, sorry, this order is mixed up. Negative root 3 over 3. There we go. Okay, so that's how I know what's happening there. Again, if you are referencing your graph, okay, I want to know tangent of what angle gives me the square root of 3. So that would put me right over here. Okay, so looking back to where I at, that would be my pi over 3. So my answer is pi over 3. Again, I know pi over 6 happens before pi over 3, so that's a way of seeing it as well. Okay, so that's how we would do A, B, and C. So again, your answer should always fall within the range of the inverse function that you are using. And if it doesn't fall in there, then your answer is going to be wrong. Okay, turning the page, last problem, example number 3. So I have the theta in standard position, and I have point P. I have, which is xy. I have point Q, which is negative xy. I have point R, which is negative x negative y. And I have point X, which is x negative y. Okay, so, and that's because of all the reflections. So determine which labeled point intersects the terminal ray at the given angles. So if I am given inverse cosine of x, okay, the output is just going to be x, nothing changes. So that means that nothing changes, my answer is going to be point P. For example 3b, notice that my output is negative y. So what's giving me the output of negative y is right there. So that means that my point is going to be located at S. For C, my output is negative x. Negative x is found right there. So that would be Q. Okay, and then tangent would be negative y over x. Okay, so the slope of that line. So the slope would be my point R. Okay, so that would be how we would get our answers there. And that is our section for 3.9 part 1.